Hi, and welcome to the video about solving three-part inequalities. We've seen a little bit about this in a previous video, but we're going to look at three-part inequalities in a little bit more depth. So we're going to start by looking at the three-part inequality. It means it actually has three parts. 1 less than 4 less than 7. What does that mean? Well, it does have three different parts compared to just two parts of an inequality. But we can kind of break it up into two different inequalities. We can first look at the inequality 1 less than 4, and that's certainly a true statement. And we can also look at the second inequality 4 less than 7. And that's also true. So what this implies is since both of these parts are true, then the overall statement 1 less than 4 less than 7 is a true statement. And this three-part inequality is an implied and. So both parts have to be true. So let's consider the inequality -2 less than 0 greater than or equal to 1. What's wrong with this? What's false about this statement? Let's see. If we look at the first half, -2 less than or equal to 0, that's certainly true. But we have this and in here. The second part has to be true. 0 greater than or equal to 1. That is false. That's not a true statement. So this implies that this overall statement just doesn't work. I don't even feel comfortable writing that greater than symbol. My hand wanted to write that less than as I'm writing that because we don't see this kind of sandwiched inequality where it's less than and then greater than. That's not the structure. So you're going to see this double less than symbol up there, like we have in the 1 less than 4 less than 7. So that implies this is false. This overall statement is not okay. What we're really interested in is when we have this algebraic statement, negative, like for example, -0.5 less than x less than 1.5. When we see this, we're looking at solutions to x that work in both of these inequalities because this is an and. So it has to work in the inequality -5/10 less than x, which we know is the same as x greater than -5/10. And it has to be true for the second inequality, x less than 1 5/10 or 1.5. So we want to know, if we're looking for solutions, we want to know what all the x's that are both greater than -5/10 and less than 1.5. Well, that's the region. Those are the x's that are between -5/10 and 1.5. So this three-part inequality is a way of writing solutions to x that are between -5/10 and 1.5. So we're going to use that word between. And what are the solutions? Well, we start at -5/10 and we up to 1 5/10, including that, because it could be equal to. So it's about this between idea. And again, if we go back up, we aren't going to see this mixed inequality symbol in a true three-part inequality or compound inequality. So let's look at solving three-part inequalities. Three-part inequalities are solved like regular equations or inequalities, the same algebra rules apply of subtracting 2. But now when we say subtract 2 from both sides, we don't have both sides, we have all 3 sides. So if I want to subtract 2, I'm going to subtract 2 from all 3 parts. So the next line is going to look like -5 less than or equal to x less than 3. So we're subtracting from all 3 parts. Now, what does this statement mean? It means the solutions to our inequality are all the x's that are between -5 and +3. And that is the answer in interval notation. So we should probably check. It's always a good idea to check. What is, we're going to check one solution that is in the region, and 0 is easy. 0 is inside, so is 0 a solution? That doesn't look like an appropriate word, does it? Is 0 a solution? Well, let's see. So we're going to check just like we would any other inequality, but this time we have 3 parts to check. We have to copy all of that down and substitute 0 in for x. So we say -3 less than 2 less than 5. Is this a true statement? Is -3 less than or equal to 2? Yes. Is 2 less than 5? Yes, so that checks. So 0 is a solution. And that's good. 0 is in our interval. Now we should check something that's outside of the interval. So what's outside that's an easy number? +5, +10. Let's check 10. Is 10 a solution? So we start back with our original inequality. -3 less than or equal to 10 plus 2 less than 5. -3 less than or equal to 12 less than 5. Well, certainly -3 is less than or equal to 12. This is true. But this part, 12, is not less than 5, so that part's false. This implies, because remember, this is an implied and, they both have to be true. So that means that 10 is not a solution. And that's what we were checking, that something out of the region wasn't a solution. Okay, I'm going to erase some of this here so we can get some more real estate. Delete. Let's see. Whoop. Sometimes the delete doesn't like me. There we go. And we got some more room. So let's move up here and solve this other, this next compound or 3-part inequality. We got some fractions. Fractions are our friends, aren't they? Okay, so like any other problem involving a fraction, an algebra problem, my preferred way is to clear out the fractions or the denominators by multiplying all sides. Instead of saying both sides, we're going to have to say all sides by the common denominator. So common denominator between 5 and 10 is 10. So we're going to multiply all 3 parts by 10. So 4/5 by 10. We're going to multiply the middle part by 10. And also the 2 by 10. Even though it doesn't have a fraction, it still has to be multiplied by 10 because we're multiplying all 3 parts by 10. So when I do that, 4/5 times 10, 5 goes into 10 twice, so 2 times 4 is 8. This 10 and that 10 will undo each other, and so we have 4 minus 2m, and then we have 20, less than or equal to 20. So Looking at this middle component where my variable is, I want to subtract 4 from all sides. So that becomes 8 minus 4 is 4. We are left with negative 2m in the middle. 20 minus 4 is 16. Last step. We need to divide all 3 parts by negative 2. Dividing by a negative on all parts will flip our inequality symbols. And 4 divided by negative 2, negative 2. We're left with m. 16 divided by negative 2 is negative 8. Now this looks backwards to me. It's not that this isn't a true statement. It's just that we don't, we traditionally see things as in a 3-part inequality as less than, equal to, less than or equal to, because this doesn't imply negative 2 to negative 8. That is not true. We would not write this. What's wrong with this? Well, it's not in numerical order smallest to greatest, or least to greatest. Negative 2 is greater than negative 8, so this is backwards. So what we want to do instead is flip this around. Have negative 8, which is the smallest number, and then that's going to reverse all these inequality symbols and make my brain, who's always seen compound or 3-part inequalities written like this, kind of more happy. And you'll get used to that too as you get more experience. This is how we want to see it because we naturally think left to right, smallest to greatest, number line. That's just kind of our standard way of thinking. And then it directly translates into the interval negative 8 to negative 2 using brackets because it could be equal to. And to be thorough, we would want to check something inside this region, maybe negative 5, and something outside, 0. That would be what you would want to check. Before going on to the next video, I'd like for you to try 2 problems. I want you to solve and write in interval notation. These, so solve and write the solution in interval notation. Problem 1, negative 14 less than 7 minus x less than or equal to negative 9. Problem 2, 6 less than 2/5 x less than 20. Try both of those, bring those solutions to class, and we will see how you did.